Okay, welcome everybody. Looks like we're ready to go again. So just a couple things to get started here. A few things. Let's see. What was I going to say? Oh, stuff I was going to talk about, and then I lost my train of thought here. Oh, homework. So I see that the majority of you have signed up for the homework, which is great. So that tells me things are working. And here's what I should say. Almost everyone has signed up for the homework. If you have yet to do that, please get in there and do that immediately. And I've seen that over half of you have already completed the first assignment with 100%. That's great, right? Great start. Keep that up. Just keep doing that, right? Keep staying current. Keep staying caught up with stuff. You'll be fine. Those of you who haven't done that yet, that's okay. You're not very far behind. Just get in there. Make sure that you get the homework set up so that if there is any kind of difficulty, you can make sure that you get a hold of me and I can help you get that taken care of. If you got the homework set up, just try to start completing those first few assignments, right? Some people are plowing ahead. Some people just did the first assignment. A few people haven't done any yet. That's okay. Just try to get them done, right? That's a major portion of what this class is about, is go ahead and just trying to get those completed, okay? Another bit of information that has come out, just so you as students kind of have a heads up of where things are going. The professors, we're starting to pick classes for the spring semester, and we've been told by administration that each professor has to teach at least 50% of the time on ground in the spring. So what that means for you as students is that many more, I would say probably in the neighborhood of 60 to 70% of the offerings on campus are going to be on ground classes, okay? So, you can plan for that accordingly. I kind of suspect this class will be on ground next semester, or if you take the Math 3, that's probably, I'd say there's a good chance that's going to be on ground in the spring. Every professor has to be at least 50% on ground, and that's considering some departments you have to be on ground, like paramedics and nurses. You can't really do that through Zoom. You can't practice injecting a needle into a vein over Zoom, right? You have to actually be there in the nursing lab to do that. So there's certain classes that have to be online. Every professor has to be at least 50%, and some professors are going to choose to be online completely, right? So I would say 60 to 70%, maybe as high as 80% of our classes are going to be back to being on ground in the spring. So you should just plan accordingly. Associated to that, you should probably know Ventura College. So when you go on ground, whether it's this semester or next, it looks like there's going to be there currently is a screening process you have to go through, and you get a wristband that allows you to walk freely around campus. If you don't have that wristband, you'll be asked to go check in at those stations. The board that covers Ventura College, Oxnard College, and Moore Park College passed a resolution that starting October 15th to be on campus, that's faculty and students, there is a vaccine mandate. You should have received an email about that, telling you all about how that will work. So that would include at least the way everything is set now, that would include next semester. So some of you who, if you're in this class, you should be over 12. So you're at least eligible for the vaccine. So just be aware when you're making your plans for Ventura College in the spring, there's a vaccine mandate in place. So you'll have to decide what you're going to do about that. That information can be found on the Ventura College website, right? Again, it's not my decision. I'm not saying I'm for or against it. I'm big on science in general, but So if you're someone who has a problem with the vaccines, or your parents do, or whatever, then you can, I'm not the one to pursue that with. It was the board that made that decision. So you'll want to look into that for next semester. Those of you who are going to get the vaccine and move forward, then you're good to go, right? So yeah, so just be aware of that, so you can make decisions now. If you need to talk to your parents about what you're going to do in order to be able to take classes at Ventura College in the spring. Now is kind of the time to start those conversations so that you can decide what you're going to do. If you're a family that gets vaccines, then you'll be able to plan ahead and get them well in advance of spring, because you can't just get it like the day before. It's you have to get it and then come back, 20 days later, get the second one, and there's a whole process. So I would encourage you, if you're old enough, just take care of it yourself. If you're younger, then ask your parents to kind of help figure that out with you. You should have received emails to your Ventura College account about the vaccine mandate so that you can have all the information that you need for the spring. Okay? Let's see. Those were two things I wanted to mention. Questions. Are there any questions? Is there anyone who went in and is confused about how Delta Math works, or you are not able to get Delta Math to work, or any kind of thing that is hindering you from moving forward in the classroom, whether a homework problem, anything that you want us to take a look at? Don't be shy, right? We're not going to make fun of anyone for asking a question. It's totally safe place. That's a normal thing that we do in classes, is we ask questions. Sometimes it's the best students in the class that are asking questions, right? So no judgment on someone who's asking a question or anything like that. This is all safe to be open and ask questions. So if you have a question, throw it into chat, or if you're in Zoom, unmute yourself and ask the question, and we can get to it from there. I haven't seen any emails, and the fact that, like I say, almost everyone has signed up for Delta Math, and over half of you have completed the first assignment with 100%. That's pretty good. So that would indicate to me that people know what they're doing, and they're moving forward. One of the biggest things that I would say is a key to success in any school that you're doing, but especially in college, because a college generally has less structure than a high school. In high school, everything is very structured. In college, you'll find stuff that's structured, but maybe a little bit less so. One of the biggest differences that I've seen, and there's research to back this up about procrastination, and they say procrastination is one of the biggest things that holds back humanity as a whole, is we wait to do things that we could just do today. But there's also research that's how it works in education. The way the due dates are set, especially now where I'm giving you plenty of time to work on stuff, it's just getting stuff in by the due dates is not really ideal. If you have time now and you go, you know what, I could do those next 5 assignments, just do them. Sit down, or you go, you know what, I have time to do one more assignment, sit down, work through it. Students who get things done a few days before the due date have much stronger grades and understand material much better than students who are waiting till the last minute. So I highly encourage you, if you have the time to work on an assignment, don't tell yourself, oh, you know what, I have till Thursday to do that. I'll work on it Thursday morning. Just do it now. And then Thursday morning, if you have time, you can work on something else. I'll be putting more assignments up there so that students can work ahead if they want to. It's actually a great way to do things, because what's going to happen is right now, most of you are probably not finding this material super difficult, right? It might be hard to remember some of this stuff. I haven't looked at this, but we're going to get to stuff that's more challenging. And if you're a little bit ahead, that means you don't have to rush as fast through the challenging stuff. So just an idea for you to work on. Definitely is beneficial to do that. Okay. I'm not seeing any questions pop up, so I'm going to move ahead with some actual mathematics material. And again, I want to make this as clear as I can. So I'm saying, you've probably already heard me say this. You're going to hear me say it numerous times in the future. Just showing up to these class meetings is not enough. You need to be watching the videos that are posted in Canvas. You need to be watching the videos that are part of the Delta Math homework. If you're skipping that, you're going to get to problems where you go, I don't know how to do this problem. He never talked about that in class. Remember, we're only meeting for 40% of the time that we would meet if we were an on-ground classroom. That's less than half, significantly less than half. So it's just thinking about it that way, it's not possible for me to cover all of the material that you're going to be responsible for in this course. That's why there's videos. That's why there's videos in Canvas. That's why there's videos with the homework problems, is to help you get through that stuff so that you can progress and you can move ahead. Okay? So, make sure you're watching those videos, because I'm not going to be able to cover everything. So what I'm going to go through is try to cover what I generally will try to do in class is cover the basics that I know students struggle the most with, right? I've taught this class, like I say, for 12 years. I've taught it, I don't know how many times, dozens and dozens and dozens of times. I've probably taught this class in 12 years, probably 3-4 times a year for 12 years. I know where students get stuck, and I know where they have questions and where they struggle a little bit more. And some of those things are just from maybe a little bit of lack of practice. Like, certain skills when you get to, you just need to practice them till you're good at them. Adding fractions, okay? Adding fractions is a little bit complicated. You just got to work on them until they become second nature. If you do enough problems, adding fractions will be easy for you, right? And you might think, no way, it'll never be easy for me. If you only do 5 problems and you sort of let it intimidate you, yeah, you're probably not going to get much better at it, and it's going to take you a long time to work through them. If you sit down and work a couple dozen of them, when you finish that assignment, you still may not even feel like you're that much better. The next time you come to do it, to add some fractions, you're going to go, whoa, that happened really fast, and I got the answer right? Because there really is, it's harder to get more true than the statement practice makes perfect, right? None of us will ever be perfect at fractions. I still make mistakes from time to time, but you can get way, way better if you just do a lot of those problems. So practicing the stuff, doing the homework will help you get better at it, right? So, okay, things that I want to cover today. So we have here's an important one that comes up in this chapter, and that is expressions versus equations. Let's see if I can make this a little bigger for us. Okay, I think that's big enough. We can see that. Expressions versus equations. It's very important that you as the student know the difference between an expression and an equation. And why is this so important, right? I think a lot of times students go, why are we doing vocabulary? This is a math class. Why is my teacher making such a big deal about what's an expression and what's an equation? And the answer is we have different sets of tools that we apply to expressions than we apply to equations, right? Now, sometimes you'll do the same thing. Whether you have an expression or an equation, if inside of that expression or equation you have 5 plus 4, you're probably going to add them to get 9. So some of the very basic stuff, like arithmetic, simplifying, we do the same thing to expressions and equations. But there are other parts, and there's some of the parts the students struggle with the most in this class, where it only applies to an expression or an equation, right? I would say we run into this with the last chapter we do in this class. Students will they'll get mixed up on whether they're dealing with an expression or equation, and earlier too, but it's, the factoring chapter is another one where students get confused what they're supposed to do in the problem because they're not realizing whether it's an expression or an equation. You should always identify that, because what I see students doing is they'll take an expression and they'll treat it like an equation, but you can't do that. Or they'll take an equation and treat it like an expression, and you can't do that either. You have to recognize what you're dealing with and use the right tool for that thing, right? If you try to use the wrong tool, it's not going to work. Just like, like anything. You're trying to fix something and you grab the completely wrong tool for the job and you use it, what you're probably going to do is make everything worse, right? You could hurt yourself. You could break the tool. You could break whatever you're trying to fix because you're using the wrong tool for the job. So it's really important that we know the difference. And it's actually pretty easy to spot the difference. Here's what the difference is. An equation has an equal sign in it. That's the difference right there. Do you see an equal sign in there? Obviously, it has to make sense, right? Your expressions and your equations have to be written in a way where they're sensical. But assuming that I give you a legitimate expression and I give you a legitimate equation and I say, tell me which one is the equation, you're going to go, this one, because it has an equal sign in it. Okay? So, for example, let's do an example here to make this clear. An example of an expression would be 2x plus 3y. Oops, 3y. Oops, line break. Oh, just so you know too, I'm using in mathematics, people who use mathematics, people who publish papers in mathematics, do research, that kind of stuff, we generally write things in a it's sort of arguable whether it's a computer program, it's a scripting language, but it's called LaTeX, and it's basically for formatting mathematics. So sometimes you wonder like why I'm typing and then it's showing up as a it takes a few seconds to show up. That's because I'm using the scripting language. With mathematics, you can't type out mathematics. Like try to copy a page out of your textbook. It would take you a significantly long time to get all the exponents and subscripts and all the math scripting the way it's supposed to do. This is just a scripting language which allows you to easily and quickly write that. So that's why it takes a couple extra seconds in there. Okay, so we have our expression 2x plus 3y. Notice there's no equal sign in there. Okay, here's an equation. How about 2x plus 3y equals 6? There we go. That's an equation. It has an equal sign in it. That's the big difference. Expressions don't have an equal sign. Equations do have an equal sign. If you can just remember that, which is pretty basic, you'll remember this every time. And then, so basically what happens is, like, for instance, we have a rule, and we'll cover this here in the coming chapters, but you probably have seen this before. We have a rule that says we can multiply both sides of the equation by the same thing, right? In other words, I could multiply both sides of that equation that's on the screen by 2. And if I did that, I'd get what? I'd get 4x plus 6y equals 12, right? That's legitimate, but think about the statement that we're using. It says multiply both sides of the equation by 2. It's telling us this is a rule that you can use in an equation. What I sometimes do is see people try to do that for an expression. They'll say, well, I'm just going to multiply the entire expression by 2. Well, you can't do that. It doesn't work that way. You've now just doubled your quantity. So you might ask, well, what's the difference? Why can I double an equation but not double an expression? Well, think about it as a balance. A lot of times in a math book, you'll see they actually have like a scales, or like a balance where you put weights on both sides and then you can tell how heavy something is. So what they used to do is, someone would come in with a gold nugget they found during the gold rush, and you'd put that on one side of the balance, and then you'd put a known weight on the other side, say 1 gram. And you'd put weights on there until it balances out. And then since you know the weight's on the left side, you can figure out, since it's balanced, that's the same weight on the right side. And then you know how much gold you have, right? That's an example of how you do that. That's usually the picture they show for these equations, which is both sides of the equal sign have to balance out and equal each other. They have the same value. So if I have something that's balanced on the balance, I have the same weights on both sides, and then I double those weights on both sides, it's still going to balance, right? Because I've balanced both sides. I've doubled both sides, but it's still balanced because it's double what it was before. With an expression, there's no equal sign, so there's no balance. We don't have that same concept of having the same amount of weight on each side because there is no sides, right? An expression is just one thing, whereas an equation has 2 sides that are being balanced by the equal sign. So that right there is the tool O. I can multiply an entire equation by 2, but I can't just multiply an entire expression by 2, right? If you do that, you change the value of that expression. But that's like what I've just laid out is one of the common mistakes that I'll see later in this course, where we get to certain parts and people just double something. Usually we do that a lot of times we do it to get rid of fractions. We want all those denominators to go away because we don't want to have to do a bunch of fractional operations. So we clear out the fractions. You do that by multiplying by something. You can do that in an equation, not as easy in an expression. So that's where we run across why it's really important to know the difference between an expression and equation, is so that you know what is the game here? What are the rules? What am I allowed to do to this thing that I'm dealing with? Oh, it's an equation? Oh, then I can use this set of tools. Oh, it's an expression? Then I can use this other set of tools, okay? So it's actually quite important. I think a lot of times people get hung up on vocabulary because I get it. Part of the most boring parts of classes is the vocabulary, right? And then you get into some classes like anatomy where you have so many names you have to memorize and that kind of stuff, and it can be quite tedious. But here in mathematics, when we make you learn, at least the way I teach it, I don't really care about vocabulary much unless it has a mathematical importance, right? Unless it really makes a difference in how you're going to be able to do the problem, then the vocabulary does take on a significance, okay? Okay, where are we? Oh, and then variables. So what is a variable? Oops, that's not what I want. Where are we? A variable. So see these letters that are inside the expression in the equation? Almost all the time, if you see a letter, it's probably a variable, okay? Not always the case. We have a few symbols, like the letter E and the letter I. These are real common in mathematics. We generally do not use the letters E or I for variables. You will see it done from time to time. It's usually not a good idea. Why? Because E and I and pi, those stand for specific numbers. They're very special numbers that are very important in mathematics. And so since we use the letter E to mean the number E, right, then that would be confusing if I was using it as a variable. So that's why in general, if you see E, it's usually not a variable. But most of the time, if you see letters, you're going to see X, Y, M, N, S, T, R, Z gets used a lot, W, X, Y, Z. Those are all letters that are very frequently going to be used as variables in your expressions and your equations. Now, most of the time in this class, it's usually going to be X's and Y's. Once you take intermediate algebra next semester, you'll see more variables moving in. And then as you progress, you just see more and more variables getting used to the point where we actually, when we get to say like calculus, we use a whole different system of letters in a different way. But for now, if you see an X or a Y or a W, M, N, S, T, Z, they're probably a variable. So what is a variable then? Why are we putting letters into isn't math all about numbers? I would say no, right? If you just go out to the street or go downtown where people are walking around and you ask 100 people, what is mathematics? Probably 90 of them will say, oh, that's numbers. That's stuff that has numbers in it. That's actually not a true statement. In graduate school, I've taken entire courses, even in upper division mathematics, you take entire courses where numbers barely even come up at all, and they're math classes, right? So it's not just necessarily numbers. Numbers do tend to come up, but thinking of mathematics as, oh, that's just stuff with numbers in it, is actually you're missing a huge amount of what mathematics actually is, and even that affects your daily life. So what a variable is it gives us a little bit of leeway to not know or not decide what a value should be or is, right? So for instance, it may be something that I don't know. Maybe this is my, let's look at the following. Let's do this. Let's take a business example. Let's take a profit function. So this is something I would, I might do in my applied calculus class, is we come up with a profit function. P of x equals 2x squared minus x plus 3. Okay, so maybe this is my profit function. Actually, this should be... Let's just make it plus 7. I think it's going to be a little better that way. This might be my profit function. So what if I wanted to maximize my profit? Right? What if I wanted to know what's the most amount of profit I can make? Well, that means I want to know the highest point on this curve. So what I could do is I could try to evaluate things. right? We're also about to talk about exponents, which come up in this chapter. So I could evaluate this at different values. I might say, okay, so what if I want to know what my profit is when I sell 50 units of whatever it is that I'm selling? Okay, so this is called function notation. This capital P is the name of our function. A lot of times that's going to be a lowercase f for function. Or if we have to deal with two functions, we sometimes call them f and g. Those letters in that case are just numbers. They're not the variables. They're names. I think I said numbers. I meant names. They're the names of the function. In this case, a lot of times you'll name a function after a thing that helps you remember what it is, right? So say I'm doing a business and applied calculus class, which is basically business calculus, and we have a profit function, a revenue function, and a cost function. Well, I could call those f, g, and h, but I might mix them up because how am I supposed to remember if f is the profit function or the cost function or the revenue function? If you call them p, c, and r, then it's real easy to remember. P is profit, c is cost, r is revenue. So sometimes we try to be smarter. The old adage, work smarter, not harder, which you really should do both, work smart and work hard. But generally, it's to your advantage to work smarter. We'll name the functions a letter that reminds us what it is. P for profit, C for cost, R for revenue. And that just, you're much less likely to make mistakes. Half of not making mistakes in mathematics is organization, right? And a lot of times students actually do themselves a disservice and make more mistakes because they're trying to write down as little as possible. You're going to hear me say this all semester. Write more down, okay? Like if you ever think, should I write this next step out? Yes. The answer is yes. I would say 90% of my students should be writing more when they do the problem. And I know you think, well, the more I write, the more that's just making the problem take longer. It's not making the problem take longer because when you write out more stuff, like when you try to hold a bunch of different ideas in your head, your brain's not good at it, right? There's so much research out there that says two things. One, we all think we're good at multitasking. Two, none of us are good at it, okay? It's one of those things where we each think we're really good at multitasking, but when they actually do experiments in the laboratory, almost no one is, okay? We're just bad at it. So what you don't want to be doing is holding a bunch of information in your head. You don't want to be remembering, okay, these are what the variables are. Here's what the equation is. Here's what the problem's about. You should be writing it down on the paper. Instead, a student may say, oh, it's going to take me like 5 seconds to write this next line. I'm just going to skip that. Well, what happens then is you end up making a mistake. And that mistake, instead of taking you an extra 5 seconds, is going to probably take you maybe 5 minutes to find your mistake. Once you get to the end of the problem and you realize that you're wrong, so you go, oh, I just spent like 3 minutes doing this problem and it's wrong. Now you have to go back and find where your mistake occurred. And then you have to fix it. And then you have to redo the problem with the now correct way to do it. So you see how saving yourself a couple seconds of writing out information actually costs you minutes of fixing mistakes. So especially when you're first learning, write out as much as you can about the problem, okay? When you're really, like when we're doing factoring, write everything out. Once you're really good at factoring, some of you get to a point where you'll look at a problem, not every problem, but some of them you'll look at it and you can do the factoring in your head. But you're not going to do that right at the start. You're going to do that because you've written out so many problems that you start to recognize the patterns of how they work. So, write stuff down. Right. Okay, so let's say I've defined a function here. It has a name, capital P. This X here is indicating the variable that we're using. This class is single variable. Some of you will go on and take calculus. And many people only need the first semester of calculus. Some people need 4 semesters of calculus. At the end of calculus, that 4th semester, you take what's called multivariate calculus, which is where you have more than one variable occurring, okay? But for us in this algebra class, we're really just going to have one. So most of the time, this is going to be an x here. That's telling you the variable that's occurring in the rest of the polynomial, okay? So what this says is, for my function p, which we know is our profit function, it says any number that I want to input into this function, I'm going to do what? I'm going to take it over here and I'm going to square it. I'm going to multiply by -2. I'm going to subtract that value, and then I'm going to add 7, right? And actually, I put in way too big a value. This should be like, let's do like 2 so that I can walk you through it. That'll be much easier. So let's say, okay, I want to evaluate what my company will do when I sell 2 units. What's my profit going to be in that case? Well, then all you do, and this is sometimes the directions for this will say evaluate. Okay, evaluate is just a fancy word for plug this number in. Substitute this number in to your function. That's what that really means. Okay, and this x, notice how it's a variable? That's because we don't know what the value for x is. We're deciding. When I say evaluate p of 2, I'm deciding x is equal to 2. Okay, so we put, and that's not always going to be the case. Sometimes we're solving for what a variable is. In this case, we get to choose because I want to know, maybe I make tree houses, right? Like modular tree houses for people. And maybe I can only make a few a month. So I want to know, what's my profit if I make 2 of these modular tree houses and sell them? What will my profit be each month? So we plug it in. So you leave everything the same, and all you do is change the variable to that new value. So for instance, I'd have -2. Now, usually when you're substituting in like this, you want to put parentheses around the value that you're plugging in. Because notice if I just put the 2 there, it looks like, if I don't use parentheses here, let's see, let me recompile this. If I don't use parentheses and I substitute in, that looks like -22 squared, right? That's not what it's supposed to be. What it's supposed to be is this, -2 times 2 squared. So this does a couple things. One, it clarifies how the order of operations that we should be using. And I'm not thinking that it's 22 squared now. Now I can see, oh, it's 2 squared times -2. Okay? Now you're just going to go through the rest of the problem, and everywhere there's everywhere there's an x, you're going to put a 2 with some parentheses around it. So this would be -2 plus 7. Okay, see, all I did was turn the x's into 2's with parentheses around them. Now what you're going to do is use, I think it was the first assignment, order of operations. I think some of you have already been working on these order of operations. Now you're going to go through and you're going to apply that using the order of operations. So then I'll go to my next line. And we'll start to simplify this. So here, look at this first term. I've got a -2, then a multiplication, then a 2, and an exponent. So now I have to think, okay, which ones am I supposed to do? And wait, what's an exponent? We haven't even defined that yet. Remember, an exponent tells you how many times to multiply that number by itself. So if the exponent is 2, then it's going to be 2 times 2. If the exponent is 3, then it would be 2 times 2 times 2. If it was 2 to the 10th, it would be 10 2's multiplied together. Whatever that base number is, you multiply it by itself the number of times of the exponent. So in this case, I would read this as 2 to the 2nd power, which is also called 2 squared. So if you ever hear someone say, oh, 5 squared, that just means 5 to the 2nd power. 5 times 5. Okay, so here we have 2 squared, so that 2 times 2 squared is 4, because I do exponents first, right? We do exponents before multiplications. I see this happen a lot where students will make this they'll make this -2 times 2, which is 4, and then they'll square that to get 16. In this case, it might actually work out. Nope, it's not going to work out. But in most cases, like in this case, it will come out wrong. Why? Because you did your order of operations wrong. You do exponents before you do your multiplication. So I'm doing my exponents first. 2 squared is 4. 4 times -2, that's -8. Okay, so I know the first term is -8. Now what do I have over here? I have -2. Okay, so that's going to be -2. And then I have plus 7. So that's going to be plus 7. And then I'm going to simplify all of that to get, this will be what? Negative 8 minus 2 is negative 10. Plus 7 is negative 3. So that whole thing should come out to be negative 3. Okay. Now, you've got, for those basic operations, addition, subtraction, multiplication, division, you have videos available to you, both in your Delta Math assignments. Those of you who already are comfortable with those operations, you'll blast through the assignment in no time. Remember, the assignment's adaptive. If you get 5 straight problems correct, it just moves you on to the next thing. If you're missing problems, you're going to end up having to do a few extra problems there, so be careful. So in case you're forgetting how I just did that, how did I add those numbers together? If you're not completely comfortable with remembering adding, subtracting positive numbers, adding, subtracting negative numbers, that kind of stuff, you should be thinking in terms of the number line. What I recommend for students is to draw the number line. It's like what I talked about a minute ago. If you try to do the number line in your head, you're frequently going to mess it up. If you write out the number line on your paper, it's actually faster, right? There's a saying kind of in Eastern culture, and it seems to be true a lot of times, which is go slow to go fast. That's true in mathematics. It's what I was talking about a minute ago. If you go slow when you're doing something, you'll actually do a better job, and then you won't have to redo it because you won't make as many mistakes. You won't get done and go like, oh, this painting I just did is terrible. I should have taken my time, right? And you go back and have to redo it. Go slow to go fast, which means work through something properly, do it right the first time. You don't have to redo it again, okay? So draw yourself a little number line. It doesn't have to be highly detailed like this. You don't have to put every single number in there. You just have to know your basic directions. So like, and here's the key right here. Smaller goes to the left, larger goes to the right. So for instance, yeah, stitch in time saves 9, right? So, you know, taking your time to do it right the first time you'll end up being faster, right? And I see this with students. I can see this when people are working on stuff. I'll have students that write a bunch of steps, and they're finishing problems faster than the students who are trying to skip having to write as much. They're actually finishing quicker. So what did I do here? Here I said, okay, you start at 0, and this is, negative 8. So I have to move that negative 8 means I move to the left. Hold on 1 second. I got to take this call. Just give me 1 second. Hello?
Hi, this is Yaya from Advanced Veterinary Services.
Yes, hello.
Hi, you left us a message that you were going to get a puppy in a couple of days and you needed an appointment for it.
Yeah, I ended up getting an appointment with another veterinarian.
Oh, okay. I'm so sorry we couldn't get back to you sooner.
That's okay. Thanks for calling me back. Okay, bye. Oops, sorry about that. I had and I guess I wasn't muted on this YouTube, but nothing weird happened. Sorry, I had like an important call I've been waiting for that's kind of like extremely important, so I had to take that. So I apologize for the interruption to class there. There's a lot going on this week, kind of a stressful stuff going on. But so anyways, you start at 0 on your number line. Negative 8, that's less, right? If I can give you $8 or give you negative $8, which would you rather have? Well, negative $8 means I'm taking $8 from you. So you start at 0 and you move 8 units to the left. So you're going to move on that number line to the left where it says smaller. You're going to move this way 8 units. Okay, so then you stop there at negative 8. And then what are we doing? Oh, now we're subtracting another 2. Okay, so we're going to move even 2 more units to the left. Okay, so that puts us at negative 10. Now what are we going to do? Oh, add 7. So from negative 10, now we're going to move 7 units to the right. The way that I see people be most comfortable with this is think of it in terms of spending, right? Think of a checking account. If you put money into your checking account, the amount goes up. If you spend money, the amount goes down, right? So if you just think about it in terms of like these numbers, what if I had, sometimes we won't worry about overdrafts and stuff like that. But let's just say spending. Let's say you had $0 in your account and you spent 8, you're now at negative $8. You spend another 2, you're at negative $10. Okay, and you go, you know what? I just found $7 in the seat cushions of my couch. I found $7. I'm going to put that in a bank. So now you go from negative 10, put in $7, you're now at negative 3. Okay, so for a lot of people, I find that thinking about it in terms of money can help them figure out. It can help them straighten this all out. The only weird one is subtracting a negative. That one throws people sometimes. Just remember when you subtract, and I'll do a problem in just a second. When you subtract a negative, you're actually adding. And people go, well, that's weird. Subtraction usually makes things smaller, and negatives make things smaller. But think about it this way. You can still use the money realization. Excuse me, I got the hiccups. Sometimes when I talk for a couple hours in a row, I start getting the hiccups. I got to go grab a drink as soon as this class is over, some water. So a negative, remember, means that it's like a debt. You're losing money, but subtraction means you're taking that thing away. So normally, like a second ago, we were treating this negative 8 like it was a debt. Well, what if I subtracted negative 8? I'm subtracting a debt of 8. So if I subtract your debt, if you owe me $10 and I say, you don't owe me $10 anymore, it's like you just got $10. Your net worth is now $10 more, right? So erasing a debt, subtracting a negative, is really like adding value to yourself because you don't have to pay that person $10 anymore, okay? So if you can keep that straight, keep the directions on the number line straight, and then the one weird one that confuses people, subtracting a negative, think of it as eliminating a debt. And then you can see why that becomes an addition. That becomes, yes, my net worth just went up because I don't have to pay this person this amount of money anymore. If you can do that, the number line system with smaller left, larger to the right is the way to go. You're going to see me recommend regularly in this class that you do not memorize things. I mean, some things you're just going to have to kind of memorize a little bit, but a lot of students, we see this a lot. They navigated math classes in the K-12 system by memorizing every single problem that they see. They see it and they memorize, okay, when I see this, it's exactly what I'm supposed to do. But algebra gets too messy and you just can't memorize everything. You can't memorize every combination of additions and subtractions and subtracting a positive and subtracting a negative and multiplying by a negative. And you just have to remember the basic concepts of how they work. And this picture right here, smaller goes to the left, larger goes to the right, and remember that little detail so that you don't get mixed up about subtracting a negative. When we subtract a negative, that's larger. We move to the right because you're removing a debt. You're good to go. So if you're struggling with these types of problems, each time you do a problem, draw yourself a little number line. Or draw yourself a nice number line, and then just don't mark it up while you're doing a problem. And you can keep reusing that number line during your homework. So you don't have to keep drawing it every single time. Or do what I do for class here. I just Google number line and I find one. There's tons of number lines online that you can use. And eventually what will happen is this will all start to make sense to you and you won't have to draw the number line anymore. At that point, once you're good with it, you will just be able to have it in your head and you'll be comfortable with it. Okay. Right. So let's do one here that is confusing for people. Let's do a very similar problem. Instead of P of 2, let's make it P of negative 2. Right? So we can kind of think about how this would work. Okay. So we've got, and some of this function notation stuff's going to come up in the later chapters, but it's kind of relevant to what we're doing now. So I'm just bringing it up now. So P of negative 2, that means I'm just going to go through and turn all my x's into negative 2's, right? And again, this is a step I see students try to do two things at once. They try to do the substitution and the operations at the same time. That's your brain doing two different operations at once. Much more likely that you're going to make a mistake. So like, as you see, I'm actually going through, I'm doing the substitution and writing it down. Then I'm doing the simplifying and writing it down. 2 steps, not trying to combine it into one because I could easily make a mistake if I try to do that. Okay, so let's see. This will be what? Negative 2 times negative 2 squared minus, and here's where that weird one comes in where people start getting nervous. Just follow your rules. You're subtracting a -2. So just kind of think to yourself now, okay, so what does that mean when I subtract a -2? And then I'll go over it in just a second. And then we have our +7. Okay, so let's see. What is this going to mean? Well, I've got -2 squared. -2 squared is 4, right? A negative times a negative is a positive. And that's another thing. When I'm bringing this stuff up, I'm bringing it up because it's mistakes I see a lot. So I'm just explaining it so that you don't make those same mistakes. I don't want you to think that I'm sitting here complaining about how people do mathematics. I'm not. I'm pointing out common mistakes so that you won't make them when you're doing your work, right? You won't make those same mistakes. A lot of times students will come up to me and say, a negative and a negative are positive, right? No, that's not true. A negative times a negative is a positive. And they'll say, well, that's what I meant. Okay, but then I see those same students when they're adding, they'll say a negative plus a negative is positive because they're being lazy with the language. And a negative plus a negative is not a positive. So you have to be careful. It is not true to say 2 negatives make a positive. It is true to say a negative times a negative makes a positive. Then you're saying the right thing. But see how students do that where they're lazy with the language, and then that leads them to actually make mistakes down the road. So that's why it's not just that we math teachers like to be really strict. It's because we see where people kind of start to make mistakes, and we want to avoid that. So -2 squared means -2 times -2. That's 4. Times -2, we get -8. So it looks like we're going to get the same thing we got a minute ago, right? Well, this is starting to look the same. Oh, be careful. So I told you to think about it a minute ago. What does it mean if we subtract a -2? Well, that really means that we're at a +2, right? If you owe me $2, then your balance with me is -2. If I subtract that negative balance, you now have $2 extra because you don't have to pay me that $2 that you owe me. Your net worth has gone up by $2, so this becomes +2. And then, of course, +7 is always +7, right? +7. So now when we look at this, we go, okay, so if I'm at 0, okay, -8, that I'm going to move to the left because that's smaller. I'm going to move 8 units to the left, putting me at -8. +2 means I'm going to come to the right 2, so that puts me at -6. And then +7, that's going to put me, wait, did I do that wrong? No, that's right. The +7 is going to put me at +1. So this whole thing becomes +1. So that's how we evaluate. That's how we do our order of operations. That's a little bit for the future, our function notation, but we'll talk about that again when we get there. So we talked about some good stuff today, really important stuff laying the foundation for this course. Expressions versus equations. Variables are those letters in there that they're holding an unknown value. Sometimes we get to choose what that value is going to be. Sometimes we're going to solve for what that value is, right? We don't know how to do that yet. We will be learning that pretty soon here in the coming weeks. And then you learned a little bit about function values, okay? So I highly encourage you, the couple of you that haven't signed up for the homework yet, get that done immediately. And then get started on the homeworks. Those of you who have done a little bit, that's fantastic. Just start going through them. See how far you can get. I'll start putting up more homework assignments so you can go through and do more. I encourage you. Oh, a couple things about. So there's a question here. Wouldn't -2 times -4 be possible? This negative would go away when we square it because it would be -2 times -2 giving us +4. Which would then give us a -8. It's because of, so -2 squared is going to give us a positive number because -2 times -2 and the negatives cancel when we multiply them. So that's why that would become a +4. There's other situations where other things can happen. But yeah, this would definitely be a -8 because the -2 squared would be +4 times -2 would be -8. Okay. Oh, and going forward, if you have questions on the homework, feel free to email me. That's actually a great thing for us to talk about during class. But if I just randomly pick problems, it could be problems that, people don't really need to see on that day. So if you're having trouble, feel free to send me the information. Please send me a screenshot of the problem. Just screenshot it, send it to me, and then I know all the information. Sometimes students try to describe it, and they'll be like, that one problem that said to add some stuff, and I think there was a variable in it. I'm not going to be able to know what it is. But if you send me the screenshot, I can actually talk about it in class. And probably everyone can benefit from seeing it, at least if it's kind of current. If you're a month behind everyone else, then it probably won't be as beneficial to go over that. But assuming you're relatively current, then that's a great way for us to spend time, is for me to see specific problems that students want to see worked out, and then I can go over those. Okay. All I'm asking is probably best to send them to me in Canvas if you can, because then I see exactly what class you're in, and send me a screenshot. Boom. Happy to go over it in class. Okay. We have lots of time. Otherwise, I'm guessing what people need to see, right? I may cover stuff that all of you go, yeah, I totally know the difference between an expression and an equation, right? So that would be good moving forward. So I will end this class the way we always will. I'm going to shut down the YouTube stream. Good job, everybody. Anyone who wants to talk to me, I will leave Zoom open until people are done asking me questions, and I will answer any of the questions that you need answered so that you can now go move ahead in the course, and then on Tuesday, we'll move ahead with new material, and I'll start putting up more homeworks and that kind of stuff so we can move forward, okay? So thanks, everybody. Hop into Zoom if you have questions. Otherwise, enjoy your weekend. Be safe, and we'll see you later.